Okay. So for first example, we know that what happens over here. Total number of bonds are three. Three pi bonds are there, and in product what we have to see, the two pi bonds and one new sigma bond is formed. One new sigma bond is formed. Okay. तो यहाँ पर क्या हुआ, एक नया सिग्मा बॉन्ड दिख रहा है, दो पाई बॉन्ड है। अगर हम यहाँ से इसकी पोजीशन देखते हैं, दिस इज 1 2 3 4 5 6 and 7, we can say. So suppose this is 1 2 3 4 5 6 and 7, we can say. So double bond between 2 3 are shifted to 3 4. Also the double bond between 4 5 are shifted on the 5 and 6 position. It means all these pi bonds are involved in this product formation. So we can say that the reaction takes place in this way, and number of bonds involved in product formation are 3. So here we can write number of bonds involved or utilizes in product formation are 3. It is odd, and we can say therefore the system is, or this system is 4L plus 2 pi 1. This system is 4L plus 2 pi electron system. Okay. This system is 4N plus 2 pi electron system. Second one is, here this negative charge. This is negative charge, very good. And this charge is shifted from one position to another. So it means this one negative charge is equal to 1 pi bond, and this pi bond is shifted. So total number of bonds are 2. Here we can say that the total number of bonds utilizes or involved in formation of product are 2. And what is 2? 2 is even number, and we can say it is 4N pi electron system. This is 4N pi electron system. Next, last one is, these two pi bonds are intact, they are not moved anywhere, they are on same position as here. So what is the difference? So this bond will get converted into sigma bond, another pi bond will shifted over here, another this pi bond is shifted over here. It means 1 2 3. 3 bonds are involved in product formation. Here also the odd number of bond are utilized in formation of product in the formation of product Therefore it is 4N plus 2 pi electron electrocyclization reaction, or the electrocyclization reaction with 4N plus 2 system. It is 4N plus 2 pi electrocyclic reaction, or electrocyclic reaction having 4N plus 2 system. Okay. So we'll move towards the next point, that is con rotation and disrotation. That is con rotation and disrotation. कॉन रोटेशन एंड डिस रोटेशन। आपको बने रहना है वीडियो पर। अगर वीडियो ब्लर होता है, कुछ भी होता है, उस वक्त में क्या हो जाता है, ये वीडियो रिकॉर्ड हो जाता है, बाद में आप रिकॉर्डिंग भी उसकी देख सकते हो, ठीक है। अगर किसी का नेटवर्क स्लो होता है, वीडियो ब्लर भी हो रहा है, तब भी आप रिकॉर्डिंग में वो क्लियर आ जाएगा, रिकॉर्डिंग में वो क्लियर आ जाएगा। बात करते हैं आगे कि भाई इलेक्ट्रोसाइक्लाइजेशन रिएक्शन में दो रोटेशन होते हैं, एक तो कॉन रोटेशन होता है और दूसरा डिस रोटेशन होता है। So what are the con rotations and dis rotations that we have to learn in today's lecture? Okay? So electrocyclic reactions are of two types depending upon the formation of bond. Depending upon the formation of bond at the termini of unsaturation. And this can be explained that how the stereochemical features of electrocyclization reaction is. Okay? So what is con rotation and dis rotation? So con rotation and dis rotations are actually a types of rotation that is involved during the bond formation at the termini of unsaturation, and this can be used to explain the stereochemistry of electrocyclization reaction. So what is con rotation? It is the same side rotation of orbitals of termini of unsaturation at 90 degrees is called as con rotation. You don't take tension about this. What is con rotation? You can understand very easily after some time. Okay, just you remember what is the definition. Definition is the same side rotation of orbitals of the termini or lobes of the terminal orbital of unsaturation at 90 degrees is called as con rotation. Is called as con rotation. For example, I will write here, I will take one example over here. This is the unsaturated system. Suppose करते हैं, this is an unsaturated system having the lobes of termini over here. Okay? Unsaturated system with this orbital picture, they are having these two lobes at the termini of unsaturation. Okay? And this is unsaturated system. System is unsaturated. This is unsaturation and this is termini of unsaturation. If what happens, these two lobes are rotated same side. So this lobe is rotated on right hand side, another one is also right hand side, or we can say clockwise rotation. Here also clockwise rotation. So both the lobes are rotating at the clockwise, then we can say the rotation at the lobe of termini is a con rotation. The rotation at the lobe of termini is con rotation. Or for example, this is an unsaturation system, and the both lobes are rotated anti-clockwise during bond formation. To form this bond, these two orbitals must be rotated, and this rotation is anti-clockwise. This rotation is anti-clockwise. If both the lobes of termini are rotated on same side, both the lobes of the termini of unsaturations are rotated on same side, at that time we can say that the rotation is a con rotation and electrocyclic reaction is a con rotatory electrocyclic reaction. Okay? It is the same side rotation of orbitals of termini of unsaturation and this rotation should be 90 degree. It is called as con rotation. ठीक है? यहाँ पर और लिखेंगे the electrocyclic reaction are or such electrocyclic reactions are con rotatory electrocyclic. Such electrocyclic reactions are con rotatory electrocyclic reaction. Con rotatory electrocyclic reaction. ऐसे रिएक्शन को हम कॉन रोटेटरी इलेक्ट्रोसाइक्लिक रिएक्शन कहेंगे. That is, termini of unsaturation rotated either on clockwise direction or anti-clockwise rotation. Okay, either clockwise rotation or anti-clockwise rotation through 90 degree. Then we can say that it is con rotation. It is con rotation. Okay. Second type of rotation is this rotation. This rotation, and what is the this rotation? It is opposite side rotation of orbitals or lobes of orbitals of termini. It is the opposite side rotation of orbitals or lobes of orbitals, lobes of terminal orbitals. ऐसा भी लिख सकते, lobes of terminal orbital at unsaturation. Unsaturation, and it is also called as at 90 degree is called as this rotation is called as this rotation. For example, here we have, suppose this is unsaturation and these are the terminal lobes of unsaturation. So if one lobe is rotated at a clockwise direction, another lobe is rotated at anti-clockwise direction, then such unsaturations are called as con-rotatory unsaturation. Or unsaturation or lobes of unsaturations are rotated in this way. One lobe is rotating at this side, another lobe is rotating this side. Then what happened? It is disrotation. इसको हम कहेंगे ये है disrotation. या फिर दूसरी पॉसिबिलिटी क्या हो सकती है? What is the second possibility observed over here? This is one lobe of termini of unsaturation. This one is another lobe of termini of unsaturation. And if these lobes are rotated like this, one is rotating anti-clockwise direction, another is rotating clockwise direction. Okay, this is rotating like this is rotating like this. Due to this rotation, what happens? Bond formation takes place, and that result in the different stereochemical features of the product. This is clockwise, this is anti-clockwise rotation. So this is clockwise rotation. This one is anti-clockwise. This is clockwise rotation. This one is anti-clockwise. So these two rotations are called as this rotation. These two rotations are nothing but these are the this rotation. So what we have to conclude from these two examples? So during bond formation bond कैसे बनेगा? Bond बनेगा ये दो ऑर्बिटल के ओवरलैपिंग से ही तो सिग्मा बॉन्ड बनना है. जब ये सिग्मा बॉन्ड फॉर्म होगा ये ऑर्बिटल इधर रोटेट होगी, ये ऑर्बिटल इधर रोटेट होगी, तो फिर इन दोनों लोब्स के बीच में सिग्मा बॉन्ड फॉर्म होगा रोटेशन के बाद. जब ये ऑर्बिटल इधर रोटेट हो जाएगी और ये ऑर्बिटल इधर रोटेट हो जाएगी तो इन दो ऑर्बिटल के बीच सिग्मा बॉन्ड फॉर्म होगा नया. ठीक है. सो ड्यूरिंग बॉन्ड फॉर्मेशन if the rotation of lobes at same side through 90 degree is called as con rotation, and the electrocyclic reaction is a con rotatory electrocyclic reaction. And during bond formation or during electrocyclization reaction, if one orbital is rotated anti-clockwise direction, another one is rotated clockwise direction, or one is rotated clockwise, another one is rotated anti-clockwise direction, then it is this rotation. So opposite side rotation of the lobes at the termini of unsaturation during electrocyclic reaction is called as disrotatory electrocyclic reaction. So such electrocyclic reactions are disrotatory electrocyclic reaction. Disrotatory electrocyclic reaction. So whenever the electrocyclic reaction takes place, the electrocyclic reaction may take place through the con rotation, they may take place through the disrotation. And why we are studying the con rotation of electrocyclization and disrotation of electrocyclization? Because this rotation are useful to determine the stereochemistry of product in electrocyclic reaction. Why we are studying this? Because it is very useful to determine the stereochemistry of product in electrocyclization reaction. Have you written up till now? You have to write all these things or take the screenshots of these things. Then we will move towards the next point, that is how this con and disrotation is utilized to explain the stereochemistry of electrocyclic reaction. हो गया सभी का? लिख लिए ये? ठीक है, आगे बढ़ते हैं. Stereochemistry of electrocyclic reaction or use of con and disrotation, determination of stereochemistry of electrocyclic reaction. Okay? तो स्टार्ट में हेडिंग लिखेंगे यहां पर stereochemistry of electrocyclization reaction. Stereochemistry of electrocyclic reactions or electrocyclization. To determine stereochemistry of electrocyclic reaction, it is necessary to understand, or it is necessary to observe type of rotation taking place types of rotation taking place in electrocyclization or type of rotation taking place at the terminus. At the terminus. At the terminus. So what happened? I will write some points over here, or I will point out some things over here. If conrotatory electrocyclization reaction takes place, or at the termini of properly substituted substrate of electrocyclic reaction, if conrotation takes place, then stereochemistry of starting material is retained and the product will form it with same stereochemical feature. देखेंगे in conrotatory electrocyclic reaction, in conrotatory electrocyclic reaction, stereochemistry of reactant is retained in the product. What it means? It means the starting material, if has some stereochemical feature, or if it has a properly substituted starting material, the stereochemistry of that starting material is retained in the product. For example, if we can take here, this is a methyl group, this is a methyl group, okay, and suppose here it is got orbital of unsaturation, or we can take simply this is a diene, okay, and on this diene this is a termini of unsaturation, and here it has some proper substituent CH3 and H, here also H and CH3. Okay, so at the termini of unsaturation, both the substituent are different. And if you suppose that, so this is one double bond, this CH3 is on which side? Left hand side, and this CH3 is on right hand side. If we are supposing that this is CH3 and we are considering both the CH3, so this CH3 is on left hand side and this CH3 is on right hand side, means these two CH3 are on opposite side. Okay, these two CH3s are on opposite side. One CH3 is on left hand side, another is on right hand side. So both the methyl groups are on opposite side. So what happened? If we do the conrotation over here, then what happens? we have mentioned here, whenever the conrotatory electrocyclization reaction takes place, whatever the atoms or group present on in static material, whatever their side is, they are appear on the same side in the product. Okay, for example, this methyl group and this methyl group are on opposite side in the reactant, they appear opposite side in the product also. तो प्रोडक्ट क्या बनेगा? प्रोडक्ट ये बनेगा कि ये डबल बॉन्ड यहाँ पर आना है, ये डबल बॉन्ड यहाँ पर जाना है. हम ऑर्बिटल पिक्चर से भी वो बताएंगे, फिलहाल आप इतना समझिए. You can understand that what happens when conrotation will take place with the molecule and what type of stereochemical features that we will get in the product. So here what we will get? We will get this product, here formation of this sigma bond and shifting of this pi bond. This methyl group is on, suppose this is on left hand side, this is on right hand side, means they are opposite in starting material. So here we can say that they are appear opposite in the product also. One methyl group is lower side, another is on upper side. Or we can also write it as a simply by base structural formula. One methyl group is on right hand side, suppose it is towards the observer. So another methyl group on right left hand side, it is away from the observer. So overall what happened? Here also they are on opposite side. Here also they are on opposite side. So you have to write the answer either one of these, or you can write the answer like this. This is the double bond. CH3 is on this side, another CH3 is on another side. So for this you have to mention that one is above the plane, another is below the plane to represent the opposite side group. Okay. So for representation of opposite side group, one is left hand side, another is right hand side. You have to write one is bottom side, another is top side. Or you can write one is with solid wedge line, another one is dashes wedge line. What it indicates? It indicates that these two methyl groups are on opposite side, or these two CH3 groups are on opposite side. So in reactant they are opposite side, in product also they are on opposite side. It means the stereochemistry of reactants are written in the product. Stereochemistry is not changing. Stereochemistry is still same. Okay. It means we can write the explanation about this reaction that during conrotation stereochemistry is preserved. So what we can say over here, these two methyl groups are again here also they are opposite. In product opposite, in reactant they are opposite. In product they are on opposite side, in reactant also they are on opposite sides. If I take here another example, this is the CH3, okay, and this is double bond, this is the CH3, and if I will do here the conrotation, so what will be the product? Can you judge the product? Here also electrocyclization reaction takes place. The difference is what? Both the CH3 are on same side. They are on same side. Then what happened? In product also they will appear on same side. In product also they will appear on same side. Correct? So we will get here this cyclobutene. This double bond is shifted over here, formation of new double bond. This double bond is shifted over here, we will get here double bond. Here CH3, CH3. So one CH3 should be below the plane or lower side. Another CH3 is also lower side because both are on same side. I will write here, this is also on LHS left hand side. Another CH3 is also on LHS left hand side. Here H, here H. और हम इसको ऐसा भी लिख सकते हैं कि ये डबल बॉन्ड, अगर ये CH3 अबव द प्लेन है तो ये दूसरा CH3 भी अबव द प्लेन ही होगा, यानी दोनों सेम साइड रहेंगे या फिर दोनों सिस रहेंगे. तो स्टार्टिंग मटेरियल में भी दोनों सेम साइड थे, तो प्रोडक्ट में भी कैसे रहेंगे, सेम साइड ही रहेंगे। तो यहाँ पर फिर से हम ये कह सकते हैं, वी कैन से दैट कॉन रोटेशन प्रिजर्व द स्टीरियोकेमिस्ट्री। व्हाट वी हैव टू से फ्रॉम दिस टू रिएक्शन, व्हाट वी हैव टू से, कॉन रोटेशन preserves the stereochemistry. Conrotation preserve the stereochemistry. That is, whatever the stereochemistry of substituent in starting material, it is same in the product. So stereochemistry of starting material is written in the product. Okay. So conrotation is a type of rotation or is a type of electrocyclization which preserves the stereochemical features of reactant and product. So conrotation preserves the stereochemistry of reaction. Stereochemistry of reaction. Okay. यहां तक समझ में आया? Understand up till now? If conrotation is there, you have to observe termini of unsaturation. If there are two different types of atoms or group, if here two different types of atoms or group, then you can say that this methyl group is where it is on left hand side, this methyl group is on right hand side, or you can consider this hydrogen is on right hand side, another hydrogen is on left hand side. So both the hydrogen is on opposite side, so they will appear in product opposite side. Understand? So I will write another point regarding the stereochemistry. If this rotation electrocyclic reaction or this rotatory electrocyclic reaction takes place, so the stereochemistry of reactant is inverted or opposes. तो यहां पर हम लिखेंगे in this rotatory electrocyclic reaction, the stereochemistry of reactant opposes in the product. यानी यहां पर स्टीरियोकेमिस्ट्री क्या होगी, अपोजिट हो जाएगी। इसमें स्टीरियोकेमिस्ट्री क्या होगी, अपोजिट हो जाएगी। कैसे? सेम मॉलिक्यूल लेते हैं, ये लिखे सभी ने, सेम मॉलिक्यूल लेते हैं, उसका डिसरोटेशन करके देखेंगे, डिसरोटेशन करके देखेंगे और देखेंगे कि क्या होता है। तो सेम डायस्टेरियोमर हम अगर लेते हैं तो इसमें प्रोडक्ट मिलेंगे अपोजिट वाले। Okay, suppose I will take the same example and I will do the con rotation. Instead of con rotation, I will do here this rotation. Then what happened? So if the same molecule will undergo this rotation, if the same molecule will undergo this rotation or this rotatory electrocyclization, then what happened? These two are on opposite side, they will appear on same side. So opposite side reactant or the we can say groups on termini, if they are on opposite side, on this rotation they will appear on same side. On this rotation they will appear on same side. So suppose this is cyclobutene and this methyl group is on right hand side, left hand side, this is on right hand side, they are on opposite side. So if we write the product over here, so if one methyl group is on bottom side, it will appear one methyl group appear on bottom side, so another methyl group is also appear on bottom side. That is same side. In reactant they are opposite side. In product they are on same side. These two CH3 groups are on same side. और हम इसको ऐसा भी लिख सकते हैं, we can write it as a like this, both the CH3 are on same side. What it indicates, what we can conclude? We can conclude that this rotation opposes the stereochemistry of reaction. It does not preserve stereochemistry. It opposes the stereochemistry of reaction. Therefore, we can say this rotation will opposes stereochemistry of reaction. This rotation opposes the stereochemistry of reaction. Okay? If we do the disrotation of this molecule, then what happened? ठीक है, अगर हम इस मॉलिक्यूल को डिसरोटेशन करते हैं तो क्या होगा? ये लिखे ऊपर डिसरोटेशन में इलेक्ट्रोसाइक्लिक रिएक्शन जब भी होगा तो रिएक्टेंट अपोजिट साइड होंगे तो वो सेम साइड आएंगे, अगर वो सेम साइड होंगे तो अपोजिट साइड जाएंगे। ठीक है, इसको हम फर्दर लिख सकते हैं। क्या ये मिटाया जाए? आप इसको मिटाना है, लिखिए ये। इसके कुछ एग्जांपल देता हूं मैं आपको, वो एग्जांपल आपको सॉल्व करना है। ठीक है, इसके एग्जांपल सॉल्व करना है। उससे पहले मैं कुछ पॉइंट्स लिखता हूं, उसको भी नोट डाउन कीजिए आप। उससे और चीजें ये क्लियर रहेंगी, जब भी आप पढ़ेंगे आपको समझ में आएगा कि भाई हमने यहाँ पर कहा क्या है। जो इन दो रिएक्शन में वो वही बात करेंगे। एट द termini of unsaturation, if the atoms are groups, if the atoms are groups are on same side during quantum rotation, they will appear on same side in the product. Okay. Second point, at the termini of unsaturation atoms or groups are on opposite side during con rotation, they will appear on opposite side. They will appear on opposite side in the product. In the product also. In the product also. Okay. At the termini of unsaturation, if atoms or groups are on same side, during conrotation they will appear on same side in the product. If they are on opposite side, during conrotation they will appear on opposite side in the product. Third point we have to write over here. At the termini of unsaturation, at the termini of unsaturation, if the atoms or groups are on opposite sides, during this rotation. During this rotation, they will appear on same side. They will appear on same side in the product. In the product. And last point is at the termini of unsaturation if the atoms or groups are on opposite are on same side, if the atoms or groups are present on same side, during this rotation, they will appear on different side, on opposite side. Opposite side in the product. Opposite side in the product. Okay. So we'll take some examples now. We'll take some example now. So you have to write all these 4 points, and what they will shows us, or what they will say us during conrotation. If the atoms are groups on same side, appear on same side. If they are opposite side, they will appear on opposite side. But during disrotation what happened? सेम साइड ग्रुप क्या होंगे? अगर वो सेम साइड है तो वो अपोजिट साइड चले जाएंगे, अगर वो अपोजिट साइड है तो सेम साइड आ जाएंगे. When it happens during disrotation. But during conrotation what happens? If they are on same side, in product also they are on same side. If they are on opposite side, in product also they are on opposite side. Okay? So I will take some examples, and you have to answer what will be the product. This is first example. If we have, this is double bond, here Cl, double bond. Conrotation, write the product. Okay, this is your homework. You have to write the product and stereochemistry of product. Suppose this conrotation takes place. Another example. Here we have double bond, Cl and Cl. On this rotation, what kind of product we will get? Example number 3, we will discuss all this example in next lecture. Later on, that or you have to answer this, okay? Or you have to answer this. If you are not answering, then I will explain. But here you have to try to answer all these examples. Here we have double bond, single bond, double bond, single bond, double bond. Here CH3, H, CH3. Conrotation, find the product. Whatever the possible product. Double bond, CH3. Here double bond, CH3, this is H, this is H. This is CH3, this one is CH3. Double bond, single bond, double bond. This rotation. Okay? Also, I will write here conrotation. What happened? I will write here disrotation. What happened? I will write here disrotation. What we will get? And here conrotation. Product. In every case, discon, both the rotation will take place. You have to write the answer. So you will get 1, 2, 3, 4, 5, 6, 7, 8 answers over here. Okay, we will stop here. We will meet in next lecture. Try to solve this example. Thank you very much.